Good evening, everyone. Dear students, today we are going to learn Bohr's atomic model. So, in our last lecture, we learned Rutherford's atomic model. We study the postulates or assumptions made by Rutherford, also drawbacks of Rutherford's atomic model. Niels Bohr was one of the scientists who work in this field. He modified Rutherford's atomic model. He stated three important postulates. So, what are the postulates of Bohr's atomic model? So, first one, he states that in his first postulate that for circular motion of electron around the nucleus, necessary centripetal force is provided by electrostatic force of attraction between positively charged nucleus and negatively charged electron. So, centripetal force is equal to electrostatic force by first postulate. We know the centripetal force in circular motion, it is m into v square divided by r equal to electrostatic force. In 11th standard in electrostatics we have learned that 1 by it is 4 pi epsilon naught q into q, here it is e square divided by r square. We take here only magnitude. This is centripetal force and this is electrostatic force of attraction between positively charged nucleus and negatively charged electron. Charge on electron is E, charge on proton or nucleus is E, its square. Actually charge on electron is negative, so here must be negative, but just we take here magnitude. So this is first postulate by Bohr's atomic model. So Bohr suggests first postulate that for the circular motion of electron around the nucleus, necessary centripetal force is provided by the electrostatic force of attraction between positively charged nucleus and negatively charged electron. Rutherford cannot explain why electrons revolve around the nucleus, but for motion of electron, that is circular motion, what is the reason behind that? It was suggested by Bohr. So this was first postulate suggested by Bohr. मागच्या तासात आपण रुदरफोर्डचं मॉडेल पाहिलं, त्याचे ड्रॉबॅक्स पाहिले, पण रुदरफोर्डला काही गोष्टी मांडता आल्या नाही, त्याचे ड्रॉबॅक जास्त गाजले त्याच्या मॉडेलपेक्षा ॲक्च्युली. मग त्याच्यामध्ये मॉडिफिकेशन करण्याचं काम हा नील बोर्सनी केलं आणि बोर्सनी त्याचे 3 पॉस्ट्युलेट मांडले. त्यांच्यापैकी पहिलं पॉस्ट्युलेट होतं इलेक्ट्रॉनची जी मोशन आहे सर्क्युलर न्यूक्लियसच्या भोवती, त्याला लागणारा सेंट्रिपिटल फोर्स हा इलेक्ट्रॉन आणि पॉझिटिव्ह चार्ज न्यूक्लियस यांच्यामधला सेंट्रिपिटल फोर्स प्रोव्हाइड करत असतो. तर मॅथमॅटिकली आपण असं मांडू शकतो. सो दिस इज बोर्स फर्स्ट पॉस्ट्युलेट. व्हॉट इज सेकंड पॉस्ट्युलेट सजेस्टेड बाय बोर्स? Bohr suggests that in its second postulate that it is the conditional part. The electron can revolve without radiating energy only in those permissible orbits for which its angular momentum is equal to integer multiple of h by 2 pi. So this is mathematical part of Bohr's second postulate. Bohr suggests that the electron in circular orbit in an atom can revolve without radiating energy only in those permissible orbit for which its angular momentum L is equal to integer multiple of h by 2 pi, where h is Planck's constant. We have seen the Planck's constant in last chapter. So this is the conditional part. Also you can state that electron can revolve in hydrogen atom in those permissible orbit for which its radius is having a fixed value, and that fixed value is given in terms of n or angular momentum L equal to n into h by 2 pi. So specially Bohr suggests his model or state his model only for hydrogen atom. As hydrogen consists of only one electron, only one proton, it was quite easy to explain the different postulates. So for hydrogen atom, the Bohr's atomic model, first postulate, centripetal force is provided by electrostatic force. Second postulate, electron can revolve without radiating energy only in those permissible orbit for which its angular momentum is equal to integer multiple of h by 2 pi, where h is Planck's constant. So we can write this L as it is P into R. We know angular momentum is moment of linear momentum. We know linear momentum in last standard, that is product of mass and velocity. So finally we can write here it is equal to m into v into r, where m is mass of electron, v is velocity of electron in that orbit, and r is the radius of that orbit. We can generalize this in terms of n also. So n we can state here n into h by 2 pi, p into r into m v r, where n is called as प्रिन्सिपल क्वांटम नंबर. हा n जो असतो त्याला प्रिन्सिपल क्वांटम नंबर म्हणतात. दुसरं पॉस्ट्युलेट काय म्हणतं, कंडिशनल पार्ट म्हणली बोर्सनी. इलेक्ट्रॉन सर्क्युलर ऑर्बिटमध्ये हायड्रोजन ॲटममध्ये न्यूक्लियसच्या भोवती फिरत असताना फक्त त्याच पर्टिक्युलर ऑर्बिटमध्ये फिरू शकतो ज्या ऑर्बिटमध्ये त्याचं अँग्युलर मोमेंटम हे इंटिजर मल्टिपल ऑफ h बाय 2 पाय असतं. किंवा दुसऱ्या भागामध्ये आपण असं मांडू शकतो की इलेक्ट्रॉन जेव्हा ऑर्बिटमध्ये फिरतो त्या ऑर्बिटच्या रेडियस ह्या फिक्स्ड व्हॅल्यूच्या असतात, ज्यामध्ये त्याचं अँग्युलर मोमेंटम जे असतं ते n इंटू h बाय 2 पाय इतकं असतं. L म्हणजे अँग्युलर मोमेंटम, जे की मोमेंट ऑफ लिनियर मोमेंटम असतं. मोमेंट ऑफ लिनियर मोमेंटम म्हणजे लिनियर मोमेंटम इंटू परपेंडिक्युलर डिस्टन्स, दॅट इज रेडियस ऑफ ऑर्बिट. P is equal to m into v into r, where m is mass of electron, v is velocity, and r is radius. So this is second postulate given by Bohr's atomic model. What is the third postulate now? We have to learn third postulate. 3 year. Third postulate. It is also important part. What was the problem with Rutherford and Thomson's model? Thomson's model cannot explain how energy is radiated. Rutherford also cannot explain how energy is radiated. We have seen in its drawbacks. So Bohr take care of these postulates or these models, and he suggests his model. He modify Rutherford's atomic model, and he explained quite easily how electron can radiate energy. So according to Bohr's model, his third postulate states that electron can radiate energy only when it jumps from higher energy orbit to lower energy orbit. During transition of electron from outer orbit to inner orbit, energy is radiated. जे थॉम्सनला आणि रुदरफोर्डला मांडता आलं नाही की इलेक्ट्रॉन एनर्जी रेडिएट कसा करत असतो, ते एक्सप्लेनेशन बोर्सने खूप चांगल्या पद्धतीने मांडलं. बोर्सचं म्हणणं असं होतं की इलेक्ट्रॉन कॅन रेडिएट एनर्जी ओनली व्हेन इट जम्प्स फ्रॉम आउटर ऑर्बिट, दॅट इज हायर एनर्जी ऑर्बिट, टू लोअर एनर्जी ऑर्बिट. हे कंडिशनल पार्ट जो दुसऱ्या पॉस्ट्युलेटमध्ये मांडला, विदाउट रेडिएटिंग एनर्जी इलेक्ट्रॉन फिरत असतो त्या ऑर्बिटमध्ये, जिथे अँग्युलर मोमेंटम हे इंटिजर मल्टिपल ऑफ h बाय 2 पाय असतं. पण एनर्जी कधी रेडिएट करतो त्याचं एक्सप्लेनेशन देताना बोर्सने असं मांडलं की इलेक्ट्रॉन कॅन रेडिएट एनर्जी ओनली व्हेन इट जम्प्स फ्रॉम हायर एनर्जी ऑर्बिट टू लोअर एनर्जी ऑर्बिट. अँड व्हॉट इज द अमाउंट ऑफ दॅट एनर्जी, मॅग्निट्यूड ऑफ दॅट एनर्जी? ही गेव द मॅग्निट्यूड ऑफ दॅट एनर्जी इज इक्वल टू n minus EP is equal to h into nu, where En is energy of electron in nth outer orbit and EP is energy of electron in pth inner orbit. So the difference between energy is equal to h nu, which is given by Planck's quantum theory, that energy is equal to h into nu. So this is mathematical part of Bohr's third postulate. So what is third postulate? Electron can radiate energy only when it jumps from higher energy orbit, that is outer orbit, to inner orbit, and that energy radiated is equal to difference between energies of corresponding two orbit. Here we take En as energy in nth orbit and Ep as energy in pth, inner orbit. So it is equal to h nu. So these are three important postulates suggested by Bohr. This is called Bohr's atomic model. So Bohr's atomic model, first postulate, theoretical part, electron can revolve in circular orbit around the nucleus in an atom, especially for hydrogen atom. For circular motion of electron around the nucleus, necessary centripetal force is provided by electrostatic force of attraction between positively charged nucleus and negatively charged electron. Mathematically, you can write this as: second postulate, electron can revolve in the orbits around the nucleus. That orbit has particular radius. That radius have particular value such that angular momentum of electron in those orbit equal to n into h by 2 pi. This can be stated in another words: electron can revolve without radiating energy only in those permissible orbits for which its angular momentum is equal to integer multiple of h by 2 pi. So this is conditional part. Last one, electron can radiate energy only when it jumps from outer energy orbit, that is higher energy orbit, to lower energy orbit, that is inner orbit, and that energy radiated during the transition is equal to difference between energies of corresponding orbits. So this is Bohr's atomic model. Now we have to obtain expression for radius of Bohr's orbit. So let us find the radius of Bohr's orbit. Radius of Bohr's orbit. So these are the postulates. These postulates we have to use to find the radius of Bohr's orbit. We have to use first postulate. Here we must know the physical quantities. M, it is mass of electron. V, velocity of electron. R, radius of orbit, we can say. Here E, charge on electron. Epsilon naught, it is permittivity of free space. H, it is Planck's constant. These are the important terms which we must take into consideration. So radius we have to find out. For that purpose we consider first postulate. According to first postulate of Bohr's theory, that is centripetal force is provided by electrostatic force. So we can write here by first postulate, centripetal force is equal to electrostatic force. It is E square divided by 4 pi epsilon naught into R square. If we consider this for atomic number of any different elements, it must be clear that Bohr suggests his atomic model only for hydrogen atom. Hydrogen atom consists of only one proton, only one electron. So we can consider Z is equal to 1 for hydrogen atom. बोर्सनी मांडलेलं जे मॉडेल होतं ते पर्टिक्युलरली हायड्रोजन ॲटमसाठी होतं. हायड्रोजन ॲटममध्ये एकच इलेक्ट्रॉन एकच प्रोटॉन असतो, त्याच्यामुळे त्याचा ॲटॉमिक नंबर हा 1 असतो. जर आपण दुसरे काही सबस्टन्स इलेमेंट घेतले ज्याच्यामध्ये इलेक्ट्रॉनची संख्या प्रोटॉनची संख्या जास्त असेल त्याला ॲटॉमिक नंबर झेड म्हणत असतात. मग तो जर इथं मांडला आपण तर हे इक्वेशन आपलं तयार होईल झेड इंटू ई स्क्वेअर डिवायडेड बाय 4 पाय एप्सिलॉन नॉट आर स्क्वेअर. याच्यावरून आपण वेलॉसिटीचं इक्वेशन मांडूयात. Therefore, we can write this as v square is equal to 1 r get cancel. Here it is z e square divided by, here it is 4 pi epsilon naught 1 r and here it is m. So call this as equation number 1. So we consider first Bohr's first postulate, centripetal force equal to electrostatic force. Using that relation, we obtain expression for velocity square. Now, by second postulate, Bohr's second postulate, we consider here second postulate. So, L is equal to m into v into r is equal to, it is n into h by 2 pi. Using this, we can find or we can write for velocity. So, here it is v is equal to, it is n into h divided by 2 pi, here m into small r. We can write its square. It's a square करून घ्या. Therefore, velocity square is equal to, जर velocityचा वर्ग केला, हे इक्वेशन ने वर्ग केला तर काय होतो पहा, it is n square h square divided by 4 pi square m square आणि r square. हे झालं त्याचं रिलेशन. v square equal to n square h square by 4 pi square m square आणि r square. Call this as equation number 2. Now equating this equation 1 and 2. So equate these two equations. So equating 1 and 2 we can write here, therefore, what is equation 1? It is z into e square divided by, here it is 4 pi epsilon naught small r m. It is equal to, what is second equation? It is n square h square divided by, it is 4 pi square m square and r square. So these are two equations. We equate their right hand sides. So on both sides there are same terms. Here it is 4 pi get cancelled. Epsilon naught remains same. Here 1r get cancelled. M get cancelled. So after cancelling the terms on both sides, we can write this as, therefore, here remains e square divided by only epsilon naught. Next part epsilon naught here, and on right side here remains, it is n square h square divided by pi m and 1r. Finally, you can write for r. So therefore, radius of electron in Bohr's orbit is equal to, r is equal to this epsilon naught h square n square divided by, here it must be z again, here it is z e square pi and m. So from this relation it is clear that radius of electron in nth orbit is directly proportional to n square. So radius of electron in Bohr's orbit is directly proportional to square of its principal quantum number. For hydrogen atom, z equal to 1, so you can write this as r equal to epsilon naught h square n square upon pi m e square. The same relation can be written as in terms of pi m e square. So radius of electron in Bohr's orbit is directly proportional to square of principal quantum number. So this is Bohr's radius of Bohr's orbit. To obtain expression for radius of Bohr's orbit, we consider two postulates. First postulate, centripetal force equal to electrostatic force. We write for velocity square, z into e square for atomic number for different elements excluding hydrogen atom. Call this equation number 1. We consider here second postulate, angular momentum equal to n into h by 2 pi. Using the same relation you can write for v and making square on both sides, v square equal to n square h square 4 pi square m square r square. Equating these two equations on right hand side equate केलं त्यांच्या तर z into e square upon 4 pi epsilon naught r m पहिल्या इक्वेशनची आणि दुसऱ्या इक्वेशनची n square h square upon 4 pi square m square r square. याच्यातल्या काही टर्म्स कॅन्सल होतील. उरलेला पार्ट आहे z into e square upon epsilon naught बरोबर आहे n square h square upon pi m r. शेवटी r साठी रिलेशन मांडलं तर epsilon naught h square n square divided by z e square pi आणि m. याच्यावरून क्लिअर होतं की रेडियस बोर्स ऑर्बिटची जी असते ती प्रिन्सिपल क्वांटम नंबरच्या वर्गाला डायरेक्टली प्रोपोर्शनल असते आणि याचा वापर आपल्याला वेगवेगळी गणितं सोडवण्यासाठी करायचा असतो. सो दिस इज एक्सप्रेशन फॉर रेडियस ऑफ बोर्स ऑर्बिट. सो फर्स्ट बोर्स atomic model and then expression for radius of Bohr's orbit. So this radius is called as radius of Bohr's orbit, and Bohr's orbit are those orbit for which this condition is applicable. So this is